Hey, hi. Um, Here is the second part of the video Leetcode series. Welcome you all. Today, this is the second problem in the Leetcode. So, here is the description that is mentioned. Okay. So, here the problem statement is you're given two empty linked list representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, fine. So what they ask here is there is two non-negative integer non-empty linked list array. So it should not be empty. Some linked list array is there. So the digits are stored in reverse order. So first of all it has 3 and it has 4 and it has 2 and each of their nodes contain a single digit. This in this linked list there should be only one digit of number will come. Add the two numbers and return the sum as a linked list. So here what they told is we have to add the first two element 3 4 as 7, 4 6 as 10, and it should be double digit number, right? It should be store single. So here I put 0 and carry over the 1 here, which is simply an addition. Okay, so here it will become as 8. So here we are putting it as like this. Another way of explanation here is 342 plus 465 is 708. Okay, so linked list, here they give some class for linked list where in the val it has integer value. In the next node of this it has the list node itself, which again creates another linked list. Okay, so public init, one public init is there. We can use only for initializing the value, and public init which accepts only value, and next will be nil, and again it is like 2, it accepts 2. Okay, so first of all, uh, in a business logic way, so without thinking about how we gonna loop here or whatever it is, first of all we need to think about how it is get calculated. First of all, the first node is getting here and the second node is here. They gonna add L1's value and L2's value and put it as in the first linked list node. And similarly here, so what are the variables we need? One new linked list node. So I'm gonna create where result current node, maybe current node equal to list node. We're gonna use the empty. So for this, for storing this, we need this, and one pointer node should be needed. So I'm going to put it as result node here. So for the pointer, like transferring the list node to another, so here I'm going to create one current node. I'm assigning this result node for the very first time. Okay, so and another thing is for carrying this pending item, for that we need carry. Okay, I'm assigning 0 as initial value. So we gonna loop through this L1 and L2. That may need for example we have to loop through that L1 and L2, and for getting the second value and assigning it somewhere else, we need one variable. I mean for L1 L2 it should be two variables. So here I'm assigning where A L1 and where B L2. So everything is ready. So these are all the variables it is needed. Now what is the condition for looping? So we can use while, because for we should need to have that end. Okay, so for that I'm giving while here. So while condition, so L1 dot, sorry, L1 is not equal, sorry, not L1, we just get it as A, right? So A is not equal to nil, because why it is giving like this means the next should be assigned in the while loop. So until the next is nil, it will loop. So for the A value, until it is a nil, or we should stop at B2, B also is not equal to nil, and also we need to check the carry. Carry should not equal to nil. So on those cases, while should not stop. If it is nil, A, B nil, or carry 0 means it should loop. Okay. So first of all, let first value we're gonna get from the first linked list means A dot val. Okay, so which is basically this linked list optional should be maintained here, so we're gonna give it as optional and let y equal to b value. So b dot val, and I'm gonna optional chaining. Now I'm going to sum, so that's what we're gonna store here, right? So x plus y. And one more thing here, if carry is there means that carry also need to add. As you see here, it comes as 0. 6 plus 4 is 10, and 0 is there, and 1 is a carry. Sorry, 1 is a carry, and here it will come, and 4 plus 4 is 8. Okay, so here what I'm gonna do is I'm going to add the carry 2. So how carry is calculated? So if it is again it has some value, carry means carry should be calculated as sum divided by 10, as each of the value in the linked list is not associated with uh, uh, double digit values. It always be single here. That is what here it is mentioned. Each of their nodes contains a single digit. Okay, so now I am going to assign the sum value, and sum value also I need to check it is not the entire value. If it is 11, we should not assign 11, right? So for that we can do modulo here. So I'm going to assign current dot next equal to list node. I'm going to assign it as sum modulo 10. Okay, and I'm then assigning current equal to this current dot next. Okay, and again everything is completed. So for a value I am going to assign the next, and for b value I am going to assign next. So until this b dot next or a dot next will going to nil, on that time until that this while loop will get executed. So here what I'm gonna do is I'm going to return this result node dot next. Okay, so let's try to run this. Okay, okay. Yeah, here it comes. And what is the second case? 0 0, which should give 0. And for 9, 9 9, okay, 9 9 80, sorry, 9 9 18. So 8 and carry over 1, once again 9 9 18 plus 1 9 9. So similarly this should come this side, and it reversibly doing the addition. So expected is also same. So this is a simple logic for the linked list. First of all, one should know how the linked list works, and how it is associated. Like DSA is basically important. Uh, uh, we all know that linked list has one value, and in the next part it has the another like entire list node. So as you see here, for in DSA language, what we called linked list is like it store value, it in another space it stores the pointer of the, I mean, address of the next value. This is what linked list is defined in DS, data structure language. So here in iOS we can assign it like this. Okay. So that's it for today, I think. Because we resolved, we try to submit, and let's see how it whether it accepts all the condition or not. Oh, it actually accepts. Okay. Complexity, I think 0 minute. Oh, 44 percentage of solution used 0 minutes of runtime. Okay, and okay. Oh, what's that 0 minutes millisecond runtime? Oh, they should be very very long, and we uses like 4 millisecond runtime. Oh, our logic took 4 milliseconds. Okay, so probably most of the person use 0 milliseconds. Okay. Okay. Yeah. Almost we are in the average part of resolving stuffs. So this is our solution. We can even compare the codes. Mm-hmm. It is very nice. Okay. So this is, I'm wrapping up. I think today is accepted it is. So problem list we almost got tick for two problems. We will see more on the feature, and this comes under medium category. Okay, another is also medium. So first time we solved easy, and today it is medium. Okay, so I just gave some overview about linked list. A linked list is a linear data structure, as you know. We can call it as a nodes that is connected using the pointers. Okay, each node contains, as you see, one data and the pointer. This is what in the data structure language we used to called. Okay, what are the advantages of this is like it has like we can add more and more data, and it is dynamic in size and deletion, and if you want to delete something at the beginning or in the end, it is very easy. And the only disadvantages of this is each time it actually uses a lot of memory, as per my knowledge. It uses because that pointer is a memory, right? As you see in the next part, it has another instance for the main. So that pointer takes additional memory for that. So probably array is the best one, but as one should know the DS2. So I just have it like this. Oh, this is for sum 2. To putting the, okay. Okay, fine. So this is our code. Let's see in some other video.